Hello everyone. In this tutorial we explain how to solve double integrals by hand. But before I start with explanations, let me mention the following. If you're an engineering, physics, or mathematics student, or even a computer science student, it's very important to learn to solve integrals or to compute expressions by hand. Yes, today we have computers, we have MATLAB, we have Python, Mathematica, and other programs that can compute the expressions for you. However, the best strategy to learn mathematics and calculus is to learn it in a hard way. That is, to learn how to derive the expressions by hand. Only like that you will obtain a long-lasting and real knowledge of mathematics and calculus. Here is our problem. We want to evaluate, or better to say to compute, this double integral, where this region of integration denoted by d is bounded by this line, y is equal to x minus 1, and this parabola, y squared is equal to 2x plus 6. Let's solve this problem. The first step is to find the intersection points between this line and this parabola. And to do that, we need to solve this system of equations. The first equation in the system is y is equal to x minus 1. And the second equation is y squared is equal to 2x plus 6. Let's solve this system. From the first equation, we obtain that x is equal to y plus 1. And we can substitute x in this equation, and consequently we will obtain y squared is equal to 2 multiplying y plus 1 plus 6. And let's further compute the expression on the right hand side. We have 2y plus 2 plus 6, and this is equal to 2y plus 8. Next, let's write the last equation like this. Y squared minus 2y minus 8 is equal to 0. And let's compute zeros of this quadratic equation. This equation has two solutions, and these solutions are given as follows. Namely, we can simply use the quadratic formula, and the solutions can be written like this. y1, 2 is equal to, what do we see over here? It is equal to minus b, and in our case b is minus 2. Consequently, we will have 2 plus minus square root of b squared, that is 2 squared, this is equal to 4, minus 4ac. Minus, let's write it down here, 4, multiplying a is 1, and c is minus 8. And this should be divided by 2a. In our case, a is 1. This is divided by 2. Consequently, y12 becomes 2 plus minus, and what do we see over here? Inside we will have 4, and over here we will have plus 32. And this should be divided by 2. And as the result, we obtain 2 plus minus square root of 36 divided by 2, and this is equal to 2 plus minus 6 divided by 2. From here we see that y1 is equal to 2 minus 6 divided by 2, and this is equal to minus 2, and y2 is equal to 2 plus 6, let's write it down, divided by 2, and this is 8 divided by 2, and this is equal to 4. Okay, now we have y1 and we have y2. Let's obtain x1. From the first equation, we have that x1 is equal to y1 plus 1, and consequently x1 is minus 2 plus 1 is equal to minus 1. On the other hand, over here we will have that x2 from the same equation is y2 plus 1, and we will have that x2 is equal to 4 plus 1. That is x2 is equal to 5. And we have two intersection points. The first intersection point is minus 1, minus 2, and the second intersection point is 5, 4. Now we are ready to sketch the graphs of these two functions, and we can sketch the region D. Let's sketch the graph and the region. Over here I wrote the integral and I wrote the intersection points. So here's our graph. This is our vertical axis and this is our horizontal axis. Then the horizontal axis is denoted by x and the vertical by y. And let's write here 1, 2, 3, 4, 5, and let's use the same scale over here. 1, 2, 3, 4, 5. Over here we will have minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, and minus 5. Perfect. The first intersection point is at x is equal to minus 1 and y is equal to minus 2. That is, it's over here. The second intersection point is at x is equal to 5 and y is equal to 4. Consequently, x is equal to 5 and y is equal to 4. It's over here. Next, we need to sketch the graphs of the first line and the parabola. The equation of the line is y is equal to x minus 1. And the equation of the parabola is y is equal to, or actually y squared is equal to 2x plus 6. Let's start from the line. When x is equal to 0, y is equal to minus 1. So let's denote that. When x is equal to 0, that is here, y is equal to minus 1. Consequently, the line has to pass through this point. And let's select another line, or actually another point. For example, when y is equal to 0, let's see the x value, x should be equal to 1. That is, it's over here. And consequently, our line has to pass through these 2 points as well as these 2 intersection points. So let's first of all use a dashed line to sketch our function. So it looks somehow like this. Here it is. This is probably the best I can do without a ruler. And later on, we're going to replace this dashed line by a solid line. Next, we need to draw a graph of this parabola. Y squared is equal to 2x plus 6. We already know that our parabola has to pass through these intersection points. However, we will need an additional third point to precisely sketch this parabola. Well, when y is equal to 0, we can see that x has to satisfy the equation 2x plus 6 is equal to 0. And from this equation, we obtain that x is equal to minus 3. And consequently, over here is the point, minus 3. And our parabola has to pass through this point, and through this point. And our parabola will look like this. Let me sketch it, first of all with the dashed line. It's going to somehow look like this. Then over here, we were going to go like this. And here's our parabola. Okay, now let's use dashed lines to denote the boundaries of the region. This is the boundary bounded by our parabola. Let's carefully draw it over here. You can probably do it better if you use a pen and paper. However, I'm sketching this on my computer. And over here, let's use this color for the line. And here it is. And now you will be able to nicely see the region. Let's now make this boundary to be a little bit larger or thicker. Here it is. And let's do the same for our parabola. Here it is, such that you can nicely see it. I'm doing the best I can on my computer. Still, it's not bad. It can be better, of course, always. And here it is. And let's use some other color to denote this region. For example, let's use this color. And here is our region. So let's, for example, use this line like this to denote the region. Here it is. Okay, we'll draw a hatch over here to denote our region. Looks good. Okay, almost there. Here, and let's draw one over here. And this is our region D. Perfect. Next, let's denote the points such that we know what's happening over here. This point over here is 5, 4. And this point over here is -1, -2. Okay, let me just nicely write this last one. For example, over here, -1, -2. And let's draw the equations of the first line. The first line is y is equal to x minus 1. And the parabola is y squared is equal to 2x plus 6. And that's it. That's the whole picture. To be able to solve the integral, we first need to learn how to mathematically describe this region. This region is a two-dimensional set in the two-dimensional space, and it consists of a set of points. For example, this point, then this point, and we have a large number, or better to say, an infinite number of points in this region. And mathematically, this region can be described like this. D is actually a set of points. This is how we denote sets in mathematics, where every point has a coordinate x, y, and these coordinates have to belong to this region D. That is, they have to satisfy some property. Let's see what are these properties, and let's mathematically describe them. First of all, let's see y. We can see that y is in the range from -2 to 4. That is, any y coordinate of any point in this set is in the interval from -2 to 4. So let's write it here. We write this interval like this. Okay, but how about x? X is not independent from y. We can see that x is actually varying from this line over here to this line over here, or better to say, from our straight line to our parabola. That is, if we fix any value of y, for example, if we select any point over here, we are actually fixing its value of y, and x has to go from here, that is from this boundary to this boundary. Consequently, we need to represent this boundary line and this boundary parabola as functions of x. Let's do it for the line. The equation of the line is y is equal to x minus 1. From this equation, we have that x is actually y plus 1. Good. How about this equation? That is the other boundary. We have that y squared is equal to 2x plus 6. And from this equation, we can express x. Let's do that. 2x is equal to y squared minus 6, and x is equal to 1/2 y squared minus 3. Consequently, x is in this interval, that is from this line to this line, and we can mathematically write this fact like this. We will have x over here in the middle, then the upper bound is actually this straight line, and its equation is given over here, and the lower bound is our parabola, given by this equation, 1/2 y squared minus 3. And that's it. This is how we mathematically describe the region D. And this mathematical description will help us to immediately obtain the bounds for integration. Our original integral has this form. I is equal to double integral over the region D, x multiplying y, dx dy. Since we are able to express this region D like this, we can substitute these integrals and their bounds like this. First of all, we see that y varies from -2 to 4. And these are the bounds for y. Next, let's substitute the bounds for x. We see that x varies from 1/2 y squared minus 3 to y plus 1. And what do we have over here? We will simply have x multiplying y dx dy. And over here I will denote x in order to keep in mind that these bounds are the bounds for x. That is, these are the limits for evaluating x. Let us now analyze this integral over here. How do we compute this integral? We do it like this. First of all, we are going to evaluate this inner integral. That is, first of all, we will integrate with respect to x, where y is considered as a constant. And once we evaluate this integral and we substitute the bounds or the limits, the resulting expression will only depend on y, and we will be able to solve the outer integral. That is, we will be able to integrate with respect to y, and that's the strategy. To summarize, the main challenge over here was to precisely mathematically describe the region D. If you can mathematically describe the region D, then you know how to change the limits of integrations and how to evaluate the integral. So let's evaluate this integral. Let's do it over here. This integral becomes, here's our outer integral. We are currently not evaluating it. And let's evaluate the inner integral. Over here, we will have x squared divided by 2. And let's not forget the limits, that is the bounds. The lower bound is 1/2 y squared minus 3, and the upper bound is y plus 1. And over here, in this inner integral, y is considered as a constant, so we'll just write it here, and we need to multiply everything by dy, and that's it. Next, we have integral from -2 to 4. Over here, we will simply write y over 2, and we will substitute the bounds. We will have y plus 1 squared minus 1/2 y squared minus 3 and everything squared. Then let's close the outer parentheses and we will have here dy. And over here, to make everything more clear, I erased the previous expressions and the previous graph, and I wrote again our integral. The next step is to compute this expression over here. So let's do that. Let's write it down. We need to integrate this term, y over 2 multiplying y plus 1 squared minus 1/2 y squared minus 3, everything squared, and let's close the outer bracket. So let's evaluate this. This becomes y over 2, and let's see what do we have inside. We will have y squared plus 2y plus 1. Then we will have minus over here, and let's see what do we have inside of these parentheses. We will have 1 over 4 multiplying y to the power 4. Then we will have minus 2 multiplying 1 over 2 y squared multiplying 3, and we will have here plus 9. Let's close this parentheses and this outer bracket. And let's continue simplifying this expression over here. So we will have y over 2 y squared plus 2y plus 1. And over here we will have minus 1 over 4 y to the power 4. Then over here we will have this 2 and this 2 can be cancelled, and we have 3y squared with a minus sign, and if we multiply this minus sign by this minus sign, it becomes plus. So we'll have plus 3y squared. And over here we will have minus 9. Consequently, we will have y over 2 multiplying, let's see. First of all, we'll have minus 1 over 4 multiplying y to the power 4. This term over here. Then we will have 3y squared plus y squared is 4y squared. That is, we took into account this term and this term. Then we'll have plus 2y. That is this term over here. And we are left with 1 minus 9. This is minus 8. And that's it. And finally, we will obtain this expression. Let's see. If we multiply these two terms, we obtain minus 1 over 8 y to the power 5. Then we obtain this 2 and 4 can be cancelled, and I will obtain only 2 here. So I will have plus over here 2 y to the power 3. Then over here, this 2 and 2 can be cancelled, and I'm only left with 1 here. Then I will have plus y squared. And over here, I will have y over 2 multiplying minus 8. This becomes minus 4y. And this is our final expression. And consequently, our integral becomes integral of this expression over here, minus 1 over 8 y to the power 5 plus 2y to the power 3 plus y squared minus 4y. Over here we'll have dy, and the bounds are from minus 2 to 4. Okay, so let's compute this integral term by term. First of all, over here we will obtain minus 1 over 8 multiplying y to the power 6 over 6 with the bounds minus 2, 4. Then we will have plus 2 y to the power 4 over 4 with the same bounds, minus 2, 4. Then we will have plus y to the power 3 divided by 3 with the bounds of minus 2, 4, and we will obtain minus 4 y squared over 2 with the bounds from minus 2 to 4. And here is again our integral written at the top. I erased everything to make everything to look clear. So let's evaluate this integral. Finally, we will have here minus 1 over 8 multiplying 1 over 6 is actually 1 over 48. And inside we will have, let's see, 4 to the power 6 minus 2 to the power 6. Good. Then we will have 2 divided by 4 becomes 1/2, and we will have the upper bound 4 to the power 4 minus 2 to the power 4. Then we will have 1 over 3 multiplying 4 to the power 3 minus 2 multiplying, or actually minus 2 at the power 3. Then we will have 4 divided by 2 becomes 2 with the minus sign, and inside we will have 4 to the power 2 minus 2 to the power 2. And over here you should stop and double check everything. So let's go over together the last expression. 8 multiplied by 4 is actually equal to 1, or better to say equal to 48. So let's see the bound over here, 4 to the power 6 minus 2 to the power 6. Over here we have 1 over 2, 4 to the power 4, right? Minus 2 to the power 4 plus 1 over 3, 4 to the power 3 minus 2 to the power 3, and finally we have minus 2, since 4 over 2 is 2 with the minus sign, 4 to the power 2 minus 2 to the power 2. Next, we have I is equal to minus 1 over 48. Inside of these brackets, we will have 4096 minus 2 to the power 6 is actually 64, consequently we'll have 64 here, plus 1 over 2. Inside of these brackets or parentheses we will have 4 to the power 4 is 256, and we will have minus 2 to the power 4 is 16. Good. Plus 1 over 3, and over here we have to be very careful. 4 to the power 3 is 64. However, here we will have a minus sign, and we will have minus 2 to the power 3. Minus 2 to the power 3 is actually minus 8. Consequently, we will have plus 8 over here, and this is very important. Then we'll have minus 2, and inside of these parentheses we will have obviously 16 minus 4, and that's it. Next we have our integral becomes minus 1 over 48. What do we have over here? We simply have 4032. Then we have plus 1 over 2. 256 minus 16 is 240. Then we have plus 1 over 3. What do we see over here? 64 plus 8 is actually 72. And over here we will have minus 2 multiplying 16 minus 4 is actually 12. And that's it. So our integral becomes, over here we will have minus 4032 divided by 48 is minus 84. Let's write it nicely. Then over here we will have 240 divided by 2 is plus 120. Then over here we'll have plus 72 divided by 3 is actually 24. And over here we'll have minus 24. So our result becomes minus 84 plus 120. Since 24 minus 24 is 0, we can write 0 over here. And consequently, our integral becomes 36, and that's the solution. Simple as that. It took us more than half an hour to compute this integral. However, this is a very good exercise in calculus, integration, and staying focused for a long time. Okay, that's all for today. Thanks for watching.